Hi, and welcome to Holiday Lesson 2, Quantum Superposition. This lesson comes with a warning, which is the first half of it is on the A level, but the second half is not on the A level, and if you write about it in your A level, you will get 0 marks. I'll make it very clear when we switch from one to the other, and just try and keep those two things separate. So, we start with a red laser and we fire it at 2 slits, which we call Young's slits. You've seen these before, very simple. Just imagine a wall with 2 holes in the wall. The light comes, it goes through both holes. What we now have are 2 different light sources. They're going to interact with each other, giving us constructive and destructive interference, which will give us a diffraction pattern of some description. You already know this, no problem at all. However, we also know that every particle has a de Broglie wavelength, meaning if we can get it up going quickly enough, it will start to act like a wave. So what we can do is we can get an anode and a cathode and fire a stream of electrons at these 2 Young's slits. Some will go through one door, some will go through the other door. They'll then recombine, diffract with constructive and destructive interference, and we will get a diffraction pattern. Easy. Now I must make it very clear that A-level content ends here. The fun and the quantum superposition comes if we get rid of all of the electrons save 1, and we fire exactly 1 electron at the 2 slits. You would expect it would go through one door or the other door, and if we had a detector here, we'd just get 1 ping. Instead, it goes through both doors. 1 electron goes through 2 doors, and we can tell because we get a diffraction pattern on the other side. This is what quantum superposition means. It means in more than one position. So it turns out that quantum particles are in 2 or more places simultaneously. So this electron simultaneously goes through this door and goes through this door, interacts with itself, giving constructive and destructive interference, and you still get a diffraction pattern with only 1 electron. So you think to yourself, that can't be right. Let's put a sensor in. So you put a sensor in over one of the doors to see if it went through that door or not. And the moment you put the sensor in, the diffraction pattern disappears, and the electron will either go through one door or the other door. You may have heard that some quantum experiments, observing it changes the outcome. This is what's going on here. By putting a sensor over one of the doors, we affect the outcome of the experiment, and the electron will just politely go through one or the other, and you'll just get a single ping here or a single ping here. Remove the sensor, and all of a sudden the diffraction pattern will return. So then you say, well, what is the sensor? Because there's no such thing as just a sensor, it's not magic. It turns out what the sensor is, it's a photon. You bounce a photon off the electron as it's getting close to the doors. That bounces off, and depending on the angle it bounces off, you know which door it's gone through. So you say, well, clearly the photon is messing with the electron. Something about that interaction is changing it, which is why we get a diffraction pattern if we don't bounce the photon, but if we do bounce the photon, we don't get a diffraction pattern, we just get a single ping on our sensor. So you say to yourself, what if we reduced the energy of the photon? Put less and less energy into it, so it affected the single electron less and less and less. Maybe that would solve our problem. So you reduce the energy and you reduce the energy and you reduce the energy. And you reduce it so much that eventually the diffraction pattern reappears. And you think, oh, fantastic, which door did it go through? But the less energy you put into the photon, the less accurate a prediction it will give you over which door it went through. And it turns out that exactly the point at which you can no longer tell which door it went into is the point at which the diffraction pattern will reappear. The electron knows if you can see it. I'll tell you why that is next week. There's a difficult question down in the comments. Hope you're enjoying your holiday. See you next week.